Okay, so today we're going to be going over Unit 4, but guys, we're going to do sections 1 through 3 all in this video. So the video might be a little bit longer, so make sure that you allow yourself enough time, okay? Hit pause and take a break if you need to, okay? And what we're going to learn about today is you're going to be able to describe and perform transformations on and off of a coordinate plane. Okay, now, transformations. What are transformations and why do I need to know about them? Well, first of all, guys, every single video game that you guys play is based off of transformations, what we're talking about today. Whether it's on Xbox or PlayStation or on your phone, all of these transformations play into your video games. Now, I think that's pretty cool, but you guys know me. I'm a geek, right? Okay, so let's take a look at what exactly is a transformation. Now, you guys have heard of these before. A transformation moves or changes an object or an image in some way, in some form or fashion. Okay, now I want to point something out to you guys. Okay, and the new figure is called the image. Okay, the new figure is called the image, and the original figure is called the pre-image. Now, how do we know which one is which? Well, on a graph, okay, we're going to use prime notation to help us figure out which object is which. For instance, okay, say that the pre-image is triangle PQR. Well, then once I transform it in some way, then the image then is P prime, Q prime, R prime. Okay, so if you want to come over here, that little apostrophe means prime. Okay, that's what that means. Okay, now, if you guys notice down here, it says that we go from the pre-image and then we perform a transformation and then we have an image. So the image is going to be in prime notation. There's also going to be times, guys, where we are going to translate the image again and we're going to come up with the second image, which is going to be double prime. Right? And yes, we can actually make it go a third time and a fourth time and a fifth time. And oh my gosh, yes, guys, you can go up to where you have the 100th prime image. Okay? Trust me, we're not going to do that in here, but just know that you can. Okay? Now, let's do a little bit of review about what congruent means. Okay? Congruent, same size, same shape. Okay? Now, something that I want you guys to highlight or take note of. Right there, same angle measurements. Congruent images have the same angle measurements. They also have the exact same side lengths. Okay, same side lengths. And that's what we're going to be talking about. And during this section, we're going to be talking about congruence transformations. And that's when the new image is congruent to the pre-image. Okay, and those are translations, reflections, and rotations. Okay, so let's go take a look at what each one of these are. Okay, and I know that you guys have heard these terms before, but let's go through and review. All right, a translation. All right, a translation, which by the way, some of you guys know a translation as a slide, right? It's where every point on an image moves the same distance in the same direction. Okay, so that's like me moving my hands right now. I'm moving them the same direction, right? And the same distance. I'm not turning them. I'm not flipping them. Okay, they're just sliding, right? Now, when you are on a graph, okay, on a graph, you're going to use this translation rule. That says that for every point, X and Y, okay, you are going to move, okay, A, horizontally, which can be a positive or negative distance, and B, vertically, which it can also be vertical, can be up or down, right? Positive or negative. Okay, and we're going to do some examples on these, okay, as we go through. Now, the second one that we talked about was a reflection. Okay, now a reflection, and let me move this down so you guys can see this. You guys have probably heard that a reflection is also called a flip. Okay, a flip. Okay, a reflection is also a flip. Or you might have heard the term mirror, right? Because it is a transformation that uses a line, which we call the line of reflection, to reflect, okay, an image, and it looks like the mirror image. Okay, so like I just said, that line is called the line of reflection, and we're going to talk about how to find those and identify those and use them to help us determine some other things here in just a second. All right, now, guys, there's something you need to visualize. If you take an image and you fold it on the line of reflection, okay, all points that are on the pre-image will match up exactly with all the points on the image. For instance, if I take my hands and I fold them together, all of my fingers and all of my knuckles and the palm of my hand, all of those line up. Okay, so that is how a reflection works. Now, once again, okay, right here, okay, when you are on a graph, you can use these reflection rules. And page 2 has some other terms that we're going to look at. All right, line symmetry. So we just talked about the line of reflection. That's where we can fold an image over and it's a mirror image of itself. Now, line symmetry is when an image can be divided into two parts that match exactly. That means including any patterns and colors or words or numbers or anything, okay? Now, that line of reflection is called the line of symmetry. Okay, so let's talk about what that looks like. So if you guys look down here at the star, this star has 5 lines of symmetry because I can draw in one line of symmetry right there, and both the left side and the right side look exactly like each other. Well, if I draw in another line of symmetry right here, then watch, I'm going to trace it. This top side right here looks exactly like this bottom side right here. Oh, so I have another line of symmetry. Well, guys, there are actually 5 different lines of symmetry that you can draw in on a star because every single line that you fold over on itself, the star will look exactly the same. Now, in this railroad sign, there's no lines of symmetry because if I try to draw a line straight down the middle and I fold those over on top of each other, guys, the R's do not line up. Okay, the R would be backwards, wouldn't it? Okay, so this has no lines of symmetry. Okay, no lines of symmetry. All right, now, in a rectangle, notice that there's no colors inside, there's no writing inside. It will always have 2 lines of symmetry. All right, but notice the happy face. Okay, the happy face over here has 1 line of symmetry because yes, I can draw a line straight down vertically. Okay, and if I fold it over on itself, the eyes line up and the smile lines up. Okay, but if I were to try to draw a line horizontally, well, guys, that wouldn't work because the smile would then go on top of the eyes. Nope, that doesn't work. So this has only 1 line of symmetry. Okay, all right, so let's go take a look at next rotations. You guys have heard of rotations before. Let me get this bigger for us. Now, some of you know rotations as a turn, right? It's when we turn an object, okay? So that's when we turn that object, we say that it is rotated around the center of rotation. That is a fixed point, okay? So if any of you guys have ever played tetherball, right? The ball is attached to a pole and it goes around, doesn't it? Okay, so the top of the pole is the center of rotation. That's where the ball goes around. Now, the number of degrees that each point on the pre-image is rotated is called the angle of rotation. And we're going to do an example and I'm going to show you guys how we're going to find that angle of rotation. That means how many times does the object turn, and it's going to look exactly like itself. I'm going to talk more about that in just a minute. Okay, now, if we have an object that rotates 360 degrees and it becomes itself, okay, well, then we would say, hey, that's a rotation of 360 degrees. And we're going to talk about why that's important here in just a second. Okay, now, I want you guys to think about something. We can turn an image either clockwise or counterclockwise, right? I mean, think about it. On a clock, can't we turn the hands either clockwise or counterclockwise? So we can go either direction. So when we do a rotation, you have to say which direction is it going. Okay, that part is important as well. And just like we had up there before, okay, so guys, right here, when we are on a graph, okay, you can use these rotation rules. Okay, now notice these rotation rules are only valid when you rotate counterclockwise around the origin. Oh, so what happens when we go clockwise and we're not around the origin? Okay, well, I want to tell you right now, in geometry, we're going to focus just going around the origin, okay? But we are going to go counterclockwise and clockwise, okay? So if these rules are only for counterclockwise, then what happens if we're supposed to go clockwise? Well, guys, here's a little formula that you can use, okay? The counterclockwise rotation plus the clockwise rotation must equal 360 degrees. So that says that 270 degrees clockwise, so if I was to plug this in, it would be 270 degrees clockwise, is the same as a 90 degrees counterclockwise. And that's because if I wanted to find how many degrees counterclockwise do I need to go so that I can use those formulas, well, guys, I just set up an equation. X plus 270 equals 360, okay? And if I subtract 270 from either side, then it's 90 degrees counterclockwise. Okay, so that will help you to figure out, hey, how far do I need to go if I'm given a clockwise rotation? All right, so let's go look. The very last thing that is on your notes before we start the actual assignment is what's called rotational symmetry. Okay, rotational symmetry. Okay, rotate means to turn. Symmetry means that it looks the same. Okay, so an image can be either rotated clockwise or counterclockwise. Okay, and it has rotational symmetry if it appears to look exactly like itself when it is rotated less than 360 degrees. What does that mean? Well, guys, look at this star, okay? This star, if I look and I start at this point right up here, if I rotate this star, can I rotate it less than 360 degrees and it still look exactly like itself? Well, let's see. If I rotate it right here and I move the point over here, would the star still look exactly like itself? Yeah. Okay, well, what if I rotate the point and now I come over here? Will the star still look exactly like what we began with? Yes. Okay, and look, I can even rotate again, and it's going to look exactly the same. Oh, and I can go again, and it's going to look exactly the same. And then I can go back to where I originally started from. So that's when I rotate, I turn that object, and it looks exactly like what we had when we very first started rotating. Now, how many degrees does it go? Rotational symmetry says, what is the angle of rotation? Remember I talked about that in just a second ago? So that means, okay, and I'm going to draw it on here. When I rotate from this first tip to the second tip, how many degrees is that angle? How many degrees did I rotate it? Well, to figure that out, guys, rotational symmetry equals 360 divided by 5. But that's not going to be 5 for all of the objects out there, okay? Rotational symmetry is 360 degrees divided by the number of lines of symmetry. Okay, you should probably write this down. Okay, so rotational symmetry is 360 divided by the number of lines of symmetry. So notice right here, we have one line of symmetry right here. We have a second line of symmetry right here. Here's a third line of symmetry. If I can write the 3. Here's the fourth line of symmetry. Here's the fifth line of symmetry. Now, when we come to this point right here, guys, that's the same as line 1, so we're not going to count it again. So we have 5 lines of symmetry, So if we take 360 divided by 5, that gives us the measurement of that angle that I just drew in right there. Okay, so how are we going to use all of these? Well, that's what we're going to go take a look at. All right, so let's go down. And like I said, let's go take a look at number 5, and we'll start practicing all of these things that we just talked about. Okay, so guys, we're down here at number 5. And the instructions say, using a ruler, yes, use a ruler, you're going to accurately graph triangle PQR with the vertices, it gives us the vertices, and its image after the translation. Okay, and notice it gives us a translation rule right here. We're going to use that rule on the graph to move this triangle. All right, so we're going to then determine what are the coordinates for P prime, Q prime, and R prime. All right, so guys, I want you to go ahead and go graph the original pre-image triangle PQR. Okay, so you got your triangle graphed. It looks like mine. All right, so we're good to go. Okay, let's take a look at what are we supposed to do. So this says for every X and Y value, we're supposed to move the X value to the left 6, and the Y value is going to go up 4. So I can do this one of two ways. I like to count on the graph. So I'm going to go from P, and I'm going to count. I'm going to go to the left 6, 1, 2, 3, 4, 5, 6. And then I'm going to go up 4. 1, 2, 3, 4. And right here is my next point, which remember, we're dealing with the image now. So it is P prime, right? P prime. Now, on the graph, we have to look and see, okay, well, what point is that? That is at -4, +5, right? Okay, now, I can use the graph, or I can plug in the values and then use the little formula that we have up here. So I'm going to do that for Q just to show those of you that like to do that. Okay, so my original point Q, the X value is at 5, and I plug it into the translation. It says -6. Then my original Y value was -3, and then it says I go +4. So I'm going to go ahead and work that out. Well, 5 minus 6 is -1. -3 plus 4 is +1. So now I can go and graph Q prime, right? Q prime is at -1, +1. Right here is my Q prime. Okay? All right, now, I showed you guys 2 different ways to do it. I want you guys to try. I want you to go do it on your own, and I want you to see, can you guys tell me what are the coordinates for R prime? Okay, how did you guys do? Okay, whether or not you counted on the graph or you used the formula, okay, did you get that R is -6, 3? Okay, now I want you guys to notice something. Look at my picture, look at your picture. Okay, make sure that you have graphed everything accurately, that you have named the points accurately. Remember, guys, the pre-image does not have the prime notations on it. The image does have the prime notations. So if you left off the primes, go put them on there. Also, I want you guys to notice, when we translate an object, okay, we slide it. Okay, all of the points go in the same direction. Okay, they stay the same orientation. They don't rotate. They don't reflect. Okay, and the first image, the first triangle PQR is congruent to the second one, P prime, Q prime, R prime. Okay, they are the same size, same shape. All right, sorry about that, guys. You know what? Next, let's go do a reflection next. Let's go look at number 13 next. Okay, guys, before we can actually do number 13, we need to look at what are the instructions. Okay, so this says for 11 through 14, you are going to use a ruler and you're going to accurately graph and label the following. First and foremost, the very first thing, you're going to graph the line of reflection. The line of reflection is that equation right here where it says reflected over. That is the line of reflection. You're going to graph what that is. The second thing is that you're going to graph the polygon with the given points. Sometimes it's going to be a triangle. Other times it might be a quadrilateral or a pentagon. Okay, so you graph with the points. And then you're going to graph the image after the reflection over the given line. Okay, so let's go look at number 13. Okay, and I'm going to zoom in here so that we can see it nice and big. Okay, first thing is that we are going to graph the line of reflection, which is right here, y equals x. Okay, so as a reminder, okay, y equals x. Let's think about that. Okay, y equals mx plus b. You guys are familiar with that. Well, in this particular equation, our m, our slope, is just 1. There's a coefficient of 1 in front of the x over here. And our b, well, it's nothing there, so that's plus 0. So that means that it crosses the axis, the y-axis, at 0. Okay, so there's where it crosses the y-axis. And our slope is 1. So that means it goes up 1 over 1, up 1 over 1. So let's go ahead and we're going to graph in that line of reflection. Okay, and I'm going to show you guys something that might help you to distinguish, hey, how do I know which one's the line of reflection and the others? So something you can do is make the line of reflection a dotted line. Now, obviously, that's not too terribly dotted, so I'm going to put some other little slashes in here. Make your line of reflection a dotted line. That lets you know, hey, that's not part of the graph, that's not part of the picture, that's my line of reflection. Okay, so there is the line of reflection. Now, the second thing it said is to graph the polygon that it was given to you. So I want you guys to go graph the polygon ABC and then come back and we will reflect it over the line. Okay, so you guys got your triangle ABC graphed. Now we are going to reflect this triangle, meaning that we're going to flip it over our line of reflection. Now, we need to know, we're on a graph, so we need to ask ourselves, is there a rule that we can use for a line to reflect over the line y equals x? Okay, well guys, I want you to go back and look in your notes and I want you to tell me, what is the rule, or is there even a rule that we can use? Okay, hopefully you guys said, hey, Miss Smith, yes, there is a rule. It says that AB reflects to, and then the new points would be B, comma, A. That means that all I'm going to do is I'm going to switch the points. I don't have to change the sign. If there was a negative in front of the B, then I would change the sign, but there's not a positive or a negative or not a negative, so I don't need to change the sign. All I need to do is flip these points. So A prime would then, if I flip those, A prime would end up being at 1, 5. Okay, so let's go graph that. 1, 2, 3, 4, and 5. So right here is A prime. Now, I want you guys to notice something, okay, before we go on. I want you guys to notice something. That if I were to count, okay, up from A, I'd go 1, 2, 3, 4 units up to the line of reflection, and then jump over the line of reflection, 1, 2, 3, 4. That would get me to A prime. So the A and the A prime are the same distance from the line of reflection. Okay, well now I want you guys to go ahead and tell me, what do you guys think the coordinates are going to be for B prime? Okay, what about for C prime? Okay, I want you to go ahead and go graph it, and then I'm going to come back and you can compare it to mine. Okay, how did you guys do? Okay, do yours look like mine? Okay, notice that I wrote down all the points over here. Okay, and all we did was switch the A and the B, or switch the X and the Y, right? Now, if you guys notice, my black image, it flipped over the line. So the B flipped over the line to B prime, right? And the C flipped over the line to C prime. Okay, and my prime is not very good on that C, so let me make that a little bit bigger. There we go. Okay, check yours. Make sure that you're on track. Okay, if you need to erase it and redo it, please do so now. And guys, we're going to go down and we're just going to slide down this page, and I'm going to actually work out 2 problems with you guys on this page. Okay, we're going to do number 16 and 17 together, and we're going to talk about rotational symmetry and line symmetry. Okay, here we are. Okay, now the instructions say 15 through 18, we're going to use a ruler and we're going to actually accurately draw all the lines of symmetry. And then we're going to determine, does the figure have line symmetry? So remember, that means that we can fold the object on top of itself and all of the points will exactly line up. All right, so let's take a look. Well, right here, guys, if you see, I can draw a line right through there, and if I fold that figure on the line, the left side will look exactly like the right side. So there's one line. Okay, do you guys think there's more? I think so. Okay, so I bet that most of you said, hey, Miss Smith, we can also fold it to where the top will fold down and look exactly like the bottom. Yep, you are correct. So now we have two. Okay, so are there any more lines of symmetry that you guys see? Take a look for a minute. Okay, so there are two other more lines of symmetry. We can actually go from corner to corner, okay, and we can go from corner to corner. So now I've drawn in 4 lines of symmetry. Okay, so 4 lines of symmetry. So does this have line symmetry? Yes. Right? How many lines did we draw in? 4. Okay. Now, does it have rotational symmetry? Well, here's a test. Okay. If your lines of symmetry are greater than 1, then yes, you have rotational symmetry. So yes, I have rotational symmetry. Oh, now, how many degrees? Well, guys, do you remember? Okay, I said that rotational symmetry is 360 divided by the number of lines of symmetry. Okay, that's the number of degrees. So 360 divided by 4, that means that the number of degrees is 90 degrees. So that means that if we turn this object 90 degrees, every 90 degrees, it will look exactly like it is when we started. Okay? All right, now we're going to do number 17 together too, and I'm going to show you guys something on number 17. Let me get this up here. Dun, dun. There we go. All right, so on number 17, I'm going to ask you guys each of these questions. First of all, do you guys think that the baseball has line symmetry? What do you think? Okay, so if you think it has line symmetry, how many lines of symmetry do you think it has? Okay, let's see if you're on track. Okay, does this have line symmetry? And the answer to that is yes, it does have line symmetry. How many lines? This is kind of a trick question. It only has one line of symmetry right there. Only one. Because if we fold the threads on top of each other, they will exactly line up. Now, I want you guys to notice, do you notice the direction of the threads? They're like pointing, downwards, right? They're pointing down all on both sides. They're pointing down. So when we fold it, it will be the exact mirror image. Now, I bet most of you said that this has 2 lines of symmetry. Let me show you guys why that doesn't work. Okay, and again, this does not work. This is an example of it does not work. If I were to draw in this line of symmetry like that, and I'm saying that these threads right here exactly line up with those threads. Well, guys, if I were to fold that baseball up, aren't the threads going to be going the opposite direction? Yeah. So that's why it does not work, because the threads go the opposite direction once we fold it up or fold it down, as the case may be. Okay, so let me ask you this, based upon what I said just a second ago. Does the baseball have rotational symmetry? Okay, if it has rotational symmetry, how many degrees? All right, let's see what you guys said about this. Does it have rotational symmetry? And the answer is no. Now, the reason why is because right here, the lines of symmetry are not greater than 1. It equals 1, okay? Because I can only rotate this baseball one time. I can start from the very top, and when I rotate it, I have to go all the way around in order for it to look exactly the same, like the directions of the threads and everything? Well, how many degrees? Well, guys, just like we did just a second ago, you'd still take 360 divided by the number of lines of symmetry. The number of degrees is 360. Okay? All right, and I know that I did that kind of under my webcam. I apologize. 360 divided by the number of lines of symmetry. Okay, now, I know that some of you are going to have some questions about the rotational symmetry and the lines of symmetry, and that is perfectly fine. Make sure that you talk to your teacher about it during class. Okay, all right. Guys, we are going to do another example. We're going to go down to number 20 next. Go down to number 20. Okay, y'all. Here in number 20, the instructions say that what we're going to do is we're going to use a ruler. We're going to accurately graph the polygon and its image after a rotation given the number of degrees about the origin. So in number 20, you'll see here's our polygon. Okay, and here are the number of degrees that we're going to rotate around the origin. Now, notice it says that we need to write the rotation rule. So, here's what I want you guys to do first. I want you guys to go and look and see, okay, which rotation rule do you guys think we should use for a rotation that is 180 degrees counterclockwise? What do you guys think? Okay, so the rotation rule that you should have written down is that AB, okay, rotates to, that little arrow means, or it means maps to, rotates to, it changes to, and then it should be negative A, negative B. Okay, that's the rule that we're going to use. All right, now, I want you guys to go ahead and I want you to graph, okay, the pre-image, okay, and then when you're done with the pre-image, come back and let's talk about how we're going to rotate this fella. Okay, so guys, I'm going to make this a little bit, move this over so we can write this down. All right, so hopefully your triangle looks like mine. You've got that graphed. Now we're going to use this rotation rule right here, and we're going to figure out what are the new points going to be. So, okay, I start out, D is at, okay, negative 3, comma 2. D prime, okay, let me see that, D prime, I need to, notice it says negative A and negative B. So the A and the B are still going to stay where they're at, okay, so negative 3, 2, but the negative in front of the A and the B right there means you change the sign. So that becomes a positive 3 and a negative 2. Okay, so the negative in front of there just means that you change the sign. So if I graph that, I go 1, 2, 3, and then negative 2 right here. This is D prime. Okay, D prime. So I turned, and I'm going to use my pointer, and you guys can see this. I went 180 degrees counterclockwise. Okay, 180 degrees counterclockwise. Now, I'm going to do one more with you. Okay, I'll do E with you. So E starts out at negative 1, 5, and E prime, okay, I change the sign. So the negative 1 becomes positive 1. The positive 5 becomes negative 5. Okay, so E prime is at 1, negative 1, 2, 3, 4, and 5. Here is E. Okay, all right, now, I want you guys to give it a shot. I want you guys to tell me, what should the coordinates for F prime be? Give it a shot. All right, let's see how you did. Did you say that it should be at negative 4, negative 1? Remember, I don't switch the A and the B. All I do is change the sign. Okay, so negative 4, negative 1. Here is my F prime. All right, so once you guys draw in your triangle, and remember to use a ruler, right? You're going to draw in that triangle. It should look like this. All right, now, ladies and gentlemen, we've done quite a few together, okay? And I know that there are more on this particular assignment, okay? But I want you guys to take your time, make sure that you use a ruler, okay? And most importantly, guys, when you are in class finishing this assignment, make sure to ask questions. You don't have to guess. That's what us teachers are here for, right? Come ask us questions. We actually love it when you ask us questions, believe it or not. All right, guys, until the 4.6 or the 4.5 video, I'm trying to move us right along. Until the 4.5 video, I'll see you later.